Okay, Bella, thank you. All right, you're all recording now. Here we go. So last lesson, when we finished up with chapter 2F, we were looking at your stem and leaf plots and your dot plots. Really easy baby maths, okay? Just remember that when you're looking at stem and leaf plots, you have to have a key, so something like this. Understand that you got to put your numbers in order as well. Do not put them in random order. They must be in numerical order. And generally, there's pros and cons to using them, but when it comes to a lot of numbers, you might not want to use a stem and leaf plot, but it's still usable. Okay, but it says here, depending on what kind of data that you have and how much of it you have, there's different ones that you can use. But generally, we'll stick to what it has here: stem and leaf plots, dot plots, and histograms. So histograms we've looked at in the previous chapter. All right, so let's keep going. So 2G now is we're looking at summarizing the data. So you've got the data, you've got the displays, you've got it as a histogram and as a stem and leaf plot, but what the heck do you do with it? Okay, you can't just have data and not interpret it. That's when we start looking at your mean, your median, and I'm going to include the mode, or some of you have seen it as modal, same thing. Okay, that's the most frequent number. But just some refreshers on what these mean. Mean, remember, is kind of like, it's the same thing as the average. Okay, you've seen it all before. It looks like this, where you add everything. So you add all the numbers together, and then you divide it by however many numbers there are in your data. Okay, that's how you calculate the mean. Okay, the mean is the average. So add everything together, then you divide it by the number of numbers. Now, the other thing we're looking at is the median. So the median is the middle number. So this only works if you put your number in order from lowest to highest. Okay, you can't have, like, for example, a set of numbers like this. Okay, so you look at all your numbers here. You can't have this and say, oh, the middle number is this number. Yeah, that's the position of it, but you didn't put it in order. Okay, that means that that's not necessarily the middle number. Okay, so the median is the middle number. Now, just a heads up, for people that don't know how to find them, if you have, for example, like 69 numbers, okay, which is a lot of numbers, it's quite hard to find the middle number there. So to find the middle number or position of median / middle number, so if you want to find the position of it, all you have to do is this formula. So it's called n equals, I'll call it median position equals n plus 1 divided by 2. Okay, so just keep that in mind. I'll write this in your notes. This is the position of your median. So the n, okay, where n is the number of numbers. Okay, this just tells you, let's say, for example, you have 70 numbers. Okay, so to find the location of the median, after you've put it in order, it's going to be 70 plus 1 divided by 2, which is 35.5. I'll use this one as an example, so I'll scroll back down here. Okay, let's use this as an example here. I have, how many numbers do I have here? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25 numbers. Okay, I have 25 numbers. Okay, but I want to figure out where's the middle. So if I want to find the location of the middle number, it's going to be 25 plus 1 divided by 2, which is 26 over 2. So the middle number is the 13th number. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Sorry, what was that?
That's from lowest to highest.
Only if it's from lowest to highest, yeah? So you have to put it in lowest to highest. But hypothetically, if this was in lowest to highest, then this would be the middle number, okay? But you have to put it from lowest to highest. So this just tells you, so that n plus 1 divided by 2 is the position of the median. Okay, that tells you the position of your median. Okay, if you had to look for it. But generally, your calculator will do it for you, which is a good thing. All right, so if you have your CAS calculator, please get it out. We're going to put these numbers in, and we're going to put these into a, we're going to summarize the data for it. Okay, so get your calculator out, put these numbers in. Okay, so once you've put your numbers in your calculator, so you've got this, Okay, what we're going to do is we're going to summarize this data here using our calculator. Now, you can actually do this by hand if you wanted to. Add them all up, okay, and then put it in your calculator, but that's going to take a long time. You go 16 plus 16 plus 15 plus 12 plus 12 plus 11. Add them all up, and you divide it by the number of premierships, which is 18. Okay, you can add them all up, but you can actually do this on your calculator really quickly. So if you're at this step, I want you to press Menu, Actions, Statistics. Okay, so Menu, Statistics. I'll do that again. Menu, Statistics, and then you go Stat Calculations. You with me so far? Stat Calc, and then you go one variable statistic, and then just go, yep, okay for that. X list. So when you get to this menu, you have to make sure you put in premierships because that's what you're trying to calculate. So, okay, I'll go back. If you're here, follow me. Press menu. Press statistics. What do you mean? Menu. Press menu. So go to this menu here. Make sure your cursor's here somewhere. Don't leave it up there. Go here. Menu, statistics, stat calculations, one variable. Okay, and then you go OK. From there, on this X1 list, make sure you put premierships. Okay, or whatever it is you named it. Could have named it A, B, C, or whatever. Premierships. Okay, then you go OK down here. Go down, press OK. And then you'll have a bunch of numbers here, but you won't really understand all of them just yet. But the main thing to look out for is this here, with X with the line on top. That is your mean. Okay, there is your mean. And I think Elion said it was 6.5 or something. Yeah, so there it is. Calculates it for you. Nice and easy. Just premierships. It does everything. Median, it shows your median, it shows the number of numbers. There's your median, there's your Q1, Q3, maximum. It's got everything. Okay, so let's continue on. So the premierships, so the mean here. Mean, or you also see it as M with a line on top. Oh, actually, sorry, not M. X, sorry. X with a line on top is also, which also means mean, equals 6.5. Let's round it up to two numbers, 5, 6. Okay, so this is using your calculator. Hello, Jane.
Can I say Sam, please?
Yep. Okay, let's keep going.
What was it? 6.56, yeah?
Shh, 6.56, yep. Okay, so next one is the median. Okay, the median. Next part here is going to be obviously the middle number, but the median, okay, will vary depending on the number of numbers that you have. So what this is saying here, this part, is if you have an even number of your an odd number, didn't read that, odd number of numbers, your median, okay, is going to be the position of it, okay, is going to be right in the middle of between the numbers. So right in the middle of whatever the numbers are. But if it's even, like this, okay, it's going to be in between two numbers. Okay, so if you have, like, say 3, 4, 5, let's say if you have an odd number of numbers, the median is right in the middle. But if you have an even number of numbers, the median is in the middle between two numbers. Okay, that's what this is saying. Yep, add 1 divided by 2, basically.
Is there any way to change the symbols on the side of it?
No.
I was just supposed to know what they mean.
Yes, we'll explain to you guys what the symbols mean on your CAS. Okay, shh, thank you. Do you have a question, Nick? No? Okay, so let's go back to the premierships. Okay, so say if you have 18 numbers, using that formula of n plus 1 divided by 2, okay, the location is going to be n plus 1 divided by 2, so you have 18 numbers plus 1 divided by 2. That equals 19 over 2, which equals 9.5. That means your median is the 9.5th number. So if you go 1, 2, 3, 4, 5, 6, 7, 8, 9. And then in the middle right here is your median. Oops.
No.
Okay, right here in the middle.
It's gonna rest, you know what I'm saying?
So the 9.5th number.
Rap is gonna rest.
Shh. Joseph, what's my median here?
Oh, it's in between.
In between 4 and 5.
5 plus 4 is 9. Don't. Five by 2 is 4.5.
Good. 4.5. So in the middle there is your median.
Yeah.
Thank you. Okay, let's keep going. Shh. So in terms of interpreting it, you don't have to interpret it just yet, but sometimes you'll be asked to talk about the median. In terms of the interpretation here, you can see that of the AFL teams, half or 50% have won 5 or more, and the other half have won less than 4 or 4 or less. Okay, and we can see that here. You can see that half of them have won 5 or more, and the other half have won 4 or less, because the median is right in the middle. Okay, let's keep going. I've already sort of spoken about this, so I won't talk about it, but there's your formula again. So if you're looking for the median and there's a lot of numbers, n plus 1 divided by 2. Okay, let's keep going. Same thing here, you have 23 people, okay, whose numbers are displayed here. If you want to find the location of the median, n plus 1 divided by 2, that means it's 23 plus 1 divided by 2, which is 24 divided by 2. So the median position is 12. So the median isn't 12. The position is the 12th number. So you've got 1, 2, 3, 41. Yep. 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's your median. Thank you, Joseph. Easy. All right. So comparing the mean and the median. Let's talk about that. So in example 12, so let's go to this page. Elion, wake up, please. In example 12, you found the mean number of premierships, which was 6.5. And in contrast, the median was 4.5. So let me write that down. Mean is 6.5. Median is 4.5. Okay? Why are they different and which one is better? Question there for you guys. Why are they different and which one would be a better measurement? So have a think about that. Why are they different? Yeah, why is the center different to the mean?
Outliers.
Outliers, good. That could be one option. The shape, yep. So those are good actual answers. But in terms of what you guys said, there are approximate ways or exact ways to say it.
I reckon the median's better.
Yeah? Well, it really depends on the data.
On the data, yeah.
Yeah.
If it was outliers, the median's better.
Good. If there's outliers, median is generally better. What were you going to say, Leon? Elion, sorry. Same thing, yeah. So you would have learnt in year 10, which one is a better measure of the data? If your data is skewed, generally the median is better. Okay, but if it's symmetrical or approximately symmetrical, the mean is better. Okay, so, but here's a good explanation of what it has here. So it says from the stem and leaf plot, you can see that the distribution is positively skewed. So if I turn my head sideways, this data would look like this. So it starts high like this, then it goes down. So it's positively skewed. This illustrates the property of the mean. When the distribution is skewed, there are one or two very extreme values. What that means is outliers, extreme values. So you might have a lot of zeros and a lot of teens here. Okay, if that's the case, then the mean may be far from the center, meaning the mean might not be good if it's skewed. Okay, so the mean, is not necessarily a good measure of center if your data is skewed. The median is not affected by unusual observations because the median finds the middle number and isn't really affected by your outliers. So it might actually, it's always better to use median if your data is skewed, basically. That's what that's saying. You don't have to write this. Okay, that's a very long report. It's not necessary. But if it asks you which one is better, well, median is better if data is skewed. Mean is good if the data is symmetrical or approximately symmetrical. Okay, next part here, measure of spread, range, and IQR. So you might see this word, interquartile range. Shortcut for it is IQR. Okay, the range, we would have seen this before, is the simplest measure of the spread because all it does is it's the largest value, take away the smallest value. Really easy way to actually figure out the range. Highest minus lowest. Okay, pretty straightforward. Consider these two, for these two datas, what is the range for both of them? I think they're already in numerical order. So for task A, really quickly guys, what's the range or what's the calculation? 94 minus 2, which is 92. So this one's 91 minus 11, which is 80. 80. Okay, really easy. Max minus min. Now, generally, I find that the range isn't always that good, but just understand that it's maximum minus minimum. Okay. For these ones, comment on both for the range. So really easy. The highest here. So how do we read this, guys? This is going to be, what's the highest number? 94, and the lowest number? 2. So the range is 92. This one here as well, same thing. 91 minus 11, 80. Okay, thank you. Shh. Okay, have a think about this now. Is the range a good measure for the center of this data set? So, is the range a good way to explain the data? Not really. Why is that, Elion?
Because if there's outliers, then there could be like much less different.
Of possible outliers. Good. Okay, and also, the data is very much spread out, isn't it? So it's not necessarily a good way to measure the data. And also, as Elian said, these two look like outliers. So it might not be a really good measurement of that data. Okay. So if that's the case, what's a good measure for what should we use then? This data looks pretty skewed. What should I use for this one?
Median.
Good. Median is a good
I
one.
can both use median.
Yep. This one possibly median as well because there's an outlier down here. So median as well. Yeah.
If there are outliers, use median.
If there's no outliers, mean might be better, but as long as it's not skewed.
That's like symmetrical-ish.
Yeah, yeah. You don't say symmetrical-ish. Don't use that, please. Yes. All right, interquartile range. So, IQR is slightly trickier to find. Okay, but it's not that bad. Let's say, for example, you have a bunch of numbers. Let's see, where's a good one here? Okay, let's look at these list of numbers. Okay, I can split it in half, right? I've got this half, the top half, and the lower half. Okay, the interquartile range is basically the middle half of both of those datas. The middle half. So if I split this into quarters, so you've got this quarter of data and then this quarter. This is the interquartile range here. This and this. You're focusing on these numbers, the middle 50% of the data. Okay, looks a bit confusing, but let's show it to you in this example here. So find the IQR for the ranges of task A and B in example 15. Where is example 15? Here. Okay. So what I would like us to do is, if you have your calculators, I would like to put you, I'd like you guys to put these numbers in your calculator, and we'll find it really easily.
Animal tutor.
No, not quite.
Menu.
Menu statistics.
Statistics.
Which one?
Stat calculation.
Stat calc.
And then one variable or is there
One variable. Leave that as one. What do we put here? Whatever our task, whatever the variable is, so task 1. You might have called yours differently, but just scroll up because it's probably all the way up there.
What does the backwards 3x squared mean?
This is in Chinese.
This one here.
Yeah.
This one.
No, up. It's on 12.
Number 12.
Yeah.
This one.
No. I don't even know.
Backwards 3x squared. This one.
Yeah.
Yeah, so this is referring to, we haven't looked at it yet, but standard deviation and all the other numbers. But don't worry about that for now. The main things you want to focus on is, anyone remember what's the mean here?
35.67.
Good, this one here, this is the mean. Okay. What about the number of numbers? This here, the n, refers to the number of numbers, which is 30. Okay, now, Now, if you look at, anyone remember what a 5-number summary is? Okay, 5-number summary is this right here. 5 numbers that represent all the data. So you've got the minimum, the Q1, the median, the the Q3, and the maximum. 5 really important numbers that represents the data. It's called a 5-number summary.
Q1, Q3.
Okay, yep, I'll show you in a second. Shh. Sorry, I said, minimum, maximum. Okay, so the 5-number summary, okay, is what we use to actually summarize the data. Okay, when it comes to using box plots as well, we'll look into that later on. But if you look at this part of the notes, it says the IQR is Q3, take away Q1. Oops. Q3 minus Q1. So if we do Q3 minus Q1 for task A, Q3 minus Q1 is 47 minus 22. Which is 25. Okay, so that means for task A, the IQR, okay, is 25. Okay, easy. Okay, now we're going to go the long way and figure out task B without using the calculator.
Wait, what was the quote of reading again?
IQR, okay. Okay, task B, what we're going to do is we're going to now find the IQR for task B. Now, this takes a little bit longer because we have to do it by hand, but I'd like you to learn how to do it by hand so you can actually do it yourself. So what I want you to do is over here in this section, I want you to write all of the numbers for task B. So we'll just 30 numbers. Just copy them down all in one single long line, but down here.
One whole line.
Yep. Yeah, just make it small. One long line. So we're going to do it by hand. Hopefully you won't have to do it too much or too often by hand, but just so you guys understand how to do it by hand. Write all the numbers for task B in one straight line.
Oh, I can't do that.
Thank you.
So you said write it down. Write it down.
It's fine. You can write it down too. As long as, thank you.
Sorry, I'm not sorry.
As long as you're able to see all the lines in one line, because this makes this part of it easier. What you're wanting to do here, thank you guys, is on your CAS, remember I talked about the 5-number summary? You're going to do the same for this data. So you need to have the minimum, the Q1, the median, the Q3, and the maximum. So right here, I want you to write minimum, Q1, median, Q3, max. So you're going to figure out all of this. And again, you will never have to do this by hand with this many numbers because it's really annoying. Yep. Minimum, so min, Q1, median, Q3, maximum. Yeah, I'll fix this one. I will show you guys.
He will show us, right?
Okay, so first things first, let's write down the minimum and the maximum. Okay, that's easy. So you have 11 and you have 91. Easy. So you have 11 and then you have 91. The next thing is to find the median. Now, what do you do if there's too many numbers with a median?
30 plus 1 divided by 2.
Good. So what does that equal? 15.5. So that means we look for the 15.5th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that means the median is right here, between 54 and 56.
So it's just 55.
Yeah, so the median is 55. Easy. So the median is 55. All right. You said you lost. Shh. Yep. What are you lost about? Yep. We're not there yet. I'm just looking for minimum, maximum, median. Are you lost with that yet?
No.
Okay, good. Now the next part is Q1 and Q3. So Q1 is basically the middle of the lower half of the numbers. So what's the middle number here? That's what Q1 is. So if you've split it in half and you know you have 15 numbers, what's the middle number? Yeah, 7.5. So you look for the 7.5th number. Right.
So the middle number is it's between 30 and 231.
3, 4, 5, 6, 7. 7, yep. So right here.
So it's 31, isn't it?
Yep. So this is Q1 right here. I'll put it here. Which is 31.
I told you.
Yeah, does that make sense? And then what's Q3 going to be?
7.5, so 1, 2, 3, 4, 5, 6.
Middle of the upper half. So if you're looking for the 7.5th number, 1, 2, 3, 4, 5, 6, 7. Right here is Q3. Shh.
So 72.5.
So 72 and 73. So if you don't know how to calculate the middle number, just add them together, divide by 2. So the median, the Q3 there is 72.5.
Who's there winning?
So isn't it 73?
It's between 72 and 73.
Oh, I thought that was a 5.
Yeah, oh, sorry, man. That is a 3.
Oh. Wait, what?
Okay, shh. Thank you, guys. I think we're going to finish up with this because we have only a few more things left. All right, so for this one here, I've got now my 5-number summary. Really good. But the next thing to find is the IQR right here. So how do you do IQR? Look at the formula. Q3 is Q3 minus Q1. Thank you, Elion. So it's going to be 72.5. Take away the 31, which equals 41.5. Really long, I know, but we're never going to get you to do this by hand with this many numbers. It's way too much. Okay. So what can we make as a final comment? What can we say, guys, for our final comment? What has a higher IQR?
Right. I'm the, what is it? Task A.
Task B
Huh?
Task B.
has a higher IQR of 41.5 compared to,
Is that right? Write it down.
yeah, task A with 25. So just write that as a final comment when you compare them. What has a higher IQR and what is it? Okay, next part, just we'll finish off with this.
No, wait.
Sorry. No. Alright, thank you, guys. Okay, just make sure you write that sentence. So when you do your reports, we'll get into more detail about the reports later on, but your report should look something like this. Okay, task A has a higher IQR of 41.5 compared to task A. So task B has a higher compared to task A with 25. All right. So the last part here, and let's just finish off with this, is we're going to look at the standard deviation. You don't need to know too much about this for now, but just know on your calculator that the standard deviation is this symbol here. Okay, that guy. SX.
So what is this? What is the deviation?
Standard deviation.
What is that?
You learn more about it in year 12, but basically it's measuring how far from the middle a certain number is. So let's say, for example, in this classroom, the median score for your data sack is 80%. Let's go 60%. 60%. And Joseph's score, okay, in relation to the whole score was 70%. One standard deviation is 5% from the middle. So if the median was 60, Joseph got 70. He is 2 standard deviations up from the middle.
So, but why is it 1.5?
It depends on everyone's score.
Deviation.
Yeah, it depends on what everyone gets. That's why it's a deviation from the middle.
Okay.
Yeah, so it depends on your data.
Yeah.
So what's the backwards 3 mean again?
I actually don't know. We don't use that in year 11. All right. I am going to